I'm Professor Lucy Rogers, the inventor with a sense of fun. I've judged fighting machines on Robot Wars, written a book on rocket science, and even performed stand-up comedy. But now I have a new challenge. DesignSpark want me to find out how everyday tech is helping people and places do extraordinary things. From saving bees to unlocking a sixth sense. Just how are they giving themselves the engineering edge? I'm walking around the edge of this meadow and the trees are all turning colour. They're turning to that orangey brown colour. But the birds are just chittering and chattering and all getting together, ready for their long flight south. They're migrating to warmer climes. And you can just see them all. They're just jumping from tree to tree, having a good natter to each other. It's great. Oh, it's Tiffany, my producer. She's calling. Hello.
Hi, Lucy. Sounds like I've caught you outside.
I'm out in the middle of my local meadows of Woodbit. And can you hear that? You hear those birds? It's the time of year that they're all getting together and they're all going to head off south and leave us. They're all migrating.
How do they know where to go when they migrate?
They have compasses. They've got internal compasses, I'm sure.
An additional sense that we don't have, that's the mission. That's the mission for this episode. Can we use everyday tech to give humans a sixth sense?
Yeah, let's do that. I'm on it. I've spent the morning looking for people and places who are working on technologies that could help humans gain a sixth sense. And I found one. It's a company in Germany called Navibelt. So I'm calling Susan Wache because she and her two colleagues created this Navibelt. And I'm really excited to learn how it works. Hi Susan, thanks ever so much for joining us today. Can you start by explaining what is the Navibelt, please?
The Navi Belt is a belt with 16 little vibration motors. They are equally distanced around the waist and always one is vibrating. So in the normal compass mode, it's always the vibration vibrating in the direction of north. So I can feel where north is, and when I turn, it also moves around my belly or my back so that I can always feel how much I turned and which direction is north. And we also tried that with blind participants in our studies. And there we found out that it's a really, really big help for blind people. And that's how we finally made the product as a product for everyday life for blind people.
So a visually impaired person can actually wear this belt and navigate themselves around the street?
Yes, so there are two different things. Like one is the navigation part, as you mentioned. So in combination with Bluetooth and an app, you can enter a destination and then you can follow your gut feeling. So it always vibrates in the direction where you have to go. The other point, what I mentioned before, the compass mode is already really helpful for blind participants. The belt, you feel exactly when you turn. So it's not possible that you turn without noticing. And therefore, you are able to walk in straight lines without any problem.
What made you start in the first place? What made you look into this?
It was a research project in the cognitive science department. So it was brain research. And the question was, how do we learn to see? How do we learn to hear? How does that process of learning a sense work? And the idea was that you could investigate it if you just try to build a new sense. So if there's sensory information, like feeling where north is, this was just an example because humans don't have that sense, could that change your perception? Could that make you feel like a new sense? And how does that process of learning kind of a sense work? And that was the idea behind it. And therefore, we decided to try it with a magnetic sense. And this actually did kind of work.
So you've got this belt on and it's got lots of little motors around. Are they vibrating motors?
Yes.
The sort of thing that you'd get in a mobile phone, maybe?
Yes, similar. It's similar. A bit bigger so that you can feel it better, but it's similar, yes.
And so how does it all work?
So the belt has a little circuit board, and there's different sensors. There's an accelerometer, a gyroscope, and the magnetometer, so the compass. And so the belt itself, without the connection to the smartphone, knows where north is. And then with some cables connected to each of the vibromotors, it gives a signal so that the right vibromotor vibrates, which is closest to north. So this works with a normal compass, like a magnetic compass.
I assume you've actually worn this thing. What's it feel like?
I was one of the subjects of a scientific study in the beginning, because I was also a researcher in that research project. And I wore it for 2 months. Every day.
Oh, wow.
All my waking time. So it was really, really interesting. It was a kind of a sensory augmentation experience. That was also what we were investigating in the research project. And it really felt like, whether it's a new sense or not, it's more a philosophical question, I would say, but it really felt like better orientation. It was much easier. I didn't have to pay so much attention to where I am, because I just always knew.
I'm imagining if you've left your car in a big car park or something and you think, oh, was it in that direction or this direction? You might be able to get some feedback from that.
Yeah, that would be a practical use case. So yes, and together with the app, you can just press a button like save this location as a favorite, and then I can later on tell the bell, please vibrate back to this point. So, for example, also for blind people, if they are entering a forest, for example, then they can just mark the entrance of the forest, so the place they know. And then in the end, they can just press a button on the belt and it leads them back to the previously recorded position.
You say you wore it for 2 months. Did you miss it when you took it off?
Oh, yes.
Oh, really?
So in the beginning, I was not feeling the difference so much, because it was just a process over the time, because I was wearing it only with the north function, nothing else, only the north function. And after some weeks, the battery went off, because I just forgot to charge it. And I thought, it's not so different with belt or without belt. And I was standing there, oh, but where do I have to go? And where am I? And where do I come from? And then I felt the difference. And it really was a different feeling. I always, I had the impression it was like Google Street View, but everything is transparent. So I could always point into a direction where I come from without thinking about it. So one example was, for example, when someone talked to me and told me, like, where are you going today? And I was like, first I go to the office and then I go to visit my friend. I took my hand pointing in that direction, even though it was behind me, and it was always a correct direction without thinking about it. Even without a window, nothing. It was always clear where I am in comparison to all the other locations. So this was a really new experience I had not before.
And you're not visually impaired?
No, I'm completely able to see. And so seeing people, they are really different. So some people are good navigators and they know where they are. Others don't know where they are. And I'm able to navigate without problems. So I'm not one of the persons who had already problems before, but still it was so much more easy and so much more fun and relaxing, because you don't have to pay attention so much. So even though I walked through a city which I did not know with a friend, and I was talking to the friend, I did not pay attention. In the end, I still knew where I was and I could go back without problems.
Thanks ever so much, Susan. That's been a great story.
Thanks.
I absolutely love the idea of having an extra sense of knowing where north is all the time. And it's all based on something as simple and everyday as a haptic motor. So the haptic motors are ones you can control, and so you can get them to go zzz, whereas a vibrating motor in general are just ones that go zzz, 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 in a regular fashion, but you can actually control the haptic ones, and you'll probably find those in a video game, the handset, that actually gives you feedback. You might have a zzz, means turn left, or zzz means turn right. Yeah, you can really control what that is telling you. Susan has said that if I actually want to talk to someone who's using the belt daily, I should speak to Dario Madani. He lives near Frankfurt in Germany. He lost his eyesight 14 years ago, so he knew what having sight was like and what it is like to lose a sense. And by using the Navibelt, what it's like to gain a sense. Hi Dario, very good to meet you.
Hello Lucy, nice for having me.
You lost your eyesight 14 years ago. Can you take us back a little bit to there, and how has your day-to-day life changed?
I lost my eyesight within a time period of 6 months.
Wow. Mm-hmm.
So January 2006, I visited a doctor to have my eyes checked, and he told me that, yeah, it looks very bad. So pretty much 8 months later, in August, I got a surgery on my eyes, which did not work out very well. And in October, I got another surgery on my eyes, which let me wake up blind.
Mm-hmm. So what sort of things changed?
There are two things which you lose when you lose your eyesight. First of all, you lose the ability of spontaneous traveling. You know, you can't just say, yeah, I just go out, I jump into my car and I go for a ride, or, hey, let's go for a weekend abroad or whatever. That changed a lot. I was depending on help from a lot of people, especially in the first time becoming blind. I had to ask for everything, yeah. And that was pretty much against my character until then. I lost a lot of my self-confidence at that time, and that was pretty hard. And the other situation that you lose, or that I lost, was the ability to read.
Of course. So you came across the Navibelt and started wearing that. So how did that feel for you?
The ability of spontaneous traveling. And spontaneous, like saying, oh, I'm just going to go out for a walk. I just want to walk around and get my head cleared. And with the help of the belt, or with the usage of the belt, I got that back. And for me, being blind, getting things back that I thought to be lost forever is a very, very big deal and a very nice thing. So I was able to go out for a walk again, and and since I'm wearing the belt, I don't have to concentrate that much anymore when I'm outside walking, because I don't have to use my hearing for the navigation. I just use the vibration of the belt for my navigation.
Oh, so you can use your ears just for listening for traffic or the birds or whatever.
Everything which is very important for me being blind. You know, like if you walk around on the roads, or like you have to listen to the traffic. You just have to. If you miss a traffic information, that can be life-threatening. And since the belt is not like occupying your ears at all, you have a much, much safer way of walking around.
So is this why people are calling this like a sixth sense? Because it's not taking away your hearing, but you haven't got to listen to navigation over headphones or whatever. You can actually just rely on it to get to where you want to go.
Exactly.
Wow, yeah.
Yeah.
Is there anything that's, you've got back other than the walking?
Just imagine you want to pass a square, yeah, and you want to go to a bakery. Let's just take a very, very easy example. You wanna walk towards a bakery, And if you're able to see, you just focus the place where the bakery is and you walk towards the bakery, and that's it. Easy, normal, yeah? Just imagine you're blind, you're closing your eyes, and you're in the middle of this square, and you ask somebody, oh, excuse me, could you please be so kind and tell me which direction I have to turn to reach the bakery? And the person willing to help you tells you, oh, it's no problem, you just have to walk straight on. And this just is not a just for us. You know, there is no just walking straight, because you just can't walk straight as a blind person, since you don't have a point that you can focus on and that you can, target to.
So you drift, do you? You drift one way or the other?
Yeah, of course. Definitely.
Right.
So if you walk further than 10 or 20 meters, you're not going to reach your goal or your target. So with wearing the belt, I just ask, oh, could you please point out for me which direction I have to go? And the person is showing me the direction, maybe by grabbing my cane and pointing my cane into the direction, so I know where I have to go to. And the belt is helping me walking a straight line. And that is a huge, huge benefit.
So it sounds to me that you really like this belt, and so much so that you actually joined the team.
Yeah, I experienced the belt the first time in 2017 on a fair which is called Side City, and at that time it was a prototype of the actual belt, and it was we called it a boa constrictor at that time. It was a huge thing, very heavy. But I was very interested in the technique, and I thought, hey, go on with that product. And if you change the design, and if you make it smaller, and if you make it more usable, then this is a brilliant idea for each and every blind and visually impaired person in the world, to be honest. The company asked me if I would like to join the team as head of sales, and I said, yeah.
What are the future plans for the belt?
There are a lot of requests that if we could realize a waterproof belt, that blind people are able to swim straight lines. Yeah, it's another easy thing for somebody who's able to see. We're thinking about building in a system, and it's already, the technique is already there. We just have to program it. Yeah, if you fall over and you're on the floor, the system can detect if you stand up again. And if you just fall and you don't stand up in a certain time, we're thinking about connecting our app with the health app of iOS, so that there is an emergency system starting. So if you are not getting up again, that there's emergency calls getting out to whatever number, and iMessages are going to send out to whatever number.
This has been absolutely fascinating. Thanks ever so much, Dario, for joining me today and explaining how it's affected your life. Thank you.
Thank you again for having me.
Speaking with Dario has really made me want to try something like this for myself. So I'm going to make a prototype using parts that I can get from RS, and I'm going to put one vibrating motor on a hat that's connected with magnetometer, and so it'll buzz when I face north. It's going to be cool. It is a very grey and drizzly day, and I am standing on a football field, soccer pitch, and there's no one else out here, which is also good because I'm about to look really silly. I made a prototype. I've then attached that to a baseball cap. When the front of the cap is facing north, the buzzer would go off and the vibrating motor would go zzz. So to test it, it worked in the lab. First of all, I'm going to walk blindfold across the football pitch, and I know that it is 70 paces across. I've already tried that, and see how far off the centre line I walk. And then I'm going to turn around, put the cap on, walk back, hoping that the zzz noise will keep me in the right direction. And because I've actually put the cap so that north is at the front of the cap, I'm going to have to wear the cap slightly askew with, because this football pitch isn't north-south aligned. To help me a little bit, I have got an ice cream. That is my goal. That is what I am aiming to come back to. So, first of all, let me put the blindfold on. Okay, so 70 paces starting now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 64, 65, 66, 67, 68, 69, 70. Okay, give or take. How far away? Oh. Oh, I'm miles away from the centre line. Okay, I veered off to the right by about 18 steps over 70. This time I'm going to put the cap on, make sure it's aligned so that when I face down the centre line it goes beep, and see how that works. Now I do realise that I have got about 30 degrees, 15 either side of my centre line that I've got to move before it actually will go beep bob. And off I go for 70. 1, 2. Okay, I have opened up my eyes, and I had actually turned through 90 degrees. So I don't quite know what went on there, which I think just shows that a very simple prototype by me needs a lot of work to make it into a Navibelt. Right, I can see the ice cream because, you know, I keep that as an extra incentive. Be a bit of a sin not to, you know. Nom, nom. I am now in the middle of a sports field, in the rain, eating an ice cream with a hat that goes beep bop, blindfolded. I love my work. I think it's amazing that we can give ourselves a sixth sense just by using everyday technology of a vibrating motor. Even though mine didn't work too well, you could see the principle, you could see how it would work. But now I'm curious as what else could we do? What other senses, what other new senses are being created using everyday tech? And are there other people out there that are using technology to replace a lost sense or make us a little transhuman? I found someone who can tell me. I'm calling Matthew Hutson in New York. He's a science journalist and he's been diving into the world of sixth sense. Hi, Matthew. Thanks ever so much for joining me on this call today.
Yeah, thanks for having me.
You've been investigating sixth sense technologies for quite a while. What are the best ones that you've found so far?
So there's sort of a biohacker community, people who implant things into their bodies, like magnets and things. And then they put instructions online, and they have meetings where they help each other figure out how to sort of push the boundaries. So there's one that's been around for a while. It's called bottlenose. It's basically a device that you wear on your hand, like a ring. And it can have various inputs. It could use sonar or detect ultraviolet or Wi-Fi or heat. And then it can translate that into a vibration. Or if you have a little magnet implanted in your finger, then it could, make that vibrate. And so you can detect, for instance, how far away something is or how strong the Wi-Fi signal is. So people have cochlear implants to account for hearing loss.
So most of them then are, as you say, biohacks. You actually have to put something in your body first for it to react to, or for something else to react.
A lot of these things, yes. But there are also things like night vision goggles have been around for a long time, used by police and military.
Of course. So you've got the artists at one end and you've got the researchers in a lab at the other, and somewhere in the middle maybe the biohackers who are either doing it for fun or not.
Yeah. The soldiers, the military, medical researchers, the artists and biohackers. There's an interesting person named Neil Harbison who was born without the ability to see color. So he has implanted what he calls an antenna. It's sort of a camera attached to a little arm that it's sort of screwed into the back of his skull, but it reaches over the top of his head and points forward.
Sort of like an anglerfish.
Yes.
Okay.
And it turns color into vibration at different frequencies in his skull. Mm-hmm. So he can hold like an apple up to it, and he can tell the color of the apple by the way that it's vibrating his skull.
Oh, wow. So, there's uses for these things. It's not just fun.
Yeah.
And it's not just the battlefield. So you were saying about the night vision goggles have been around for quite a while. So when did people start trying to develop new senses?
Well, that's sort of, it's hard to answer. One could say that writing is a way of replacing sound, replacing speech. And Braille is another thing that it translates, you're using touch in order to perceive what people would normally see. So that's not a completely new sense. It's sort of a replacement sense. There's some other research on replacing lost senses going back to the 1960s. A researcher named Paul Bacchirita, who attached a video camera to an array of sort of metal spikes on the back of a dentist chair. So this sounds like a torture device. But someone would sit in the chair and lean back, and the spikes would vibrate at a frequency that corresponded to sort of the brightness of a pixel that the camera was picking up.
Okay, so you're effectively sitting on a picture.
Exactly. And so people could hold an object up in front of the camera, and blindfolded people sitting in the chair would be able to, after some practice, they'd be able to identify the object held up in front of them.
So has anyone done anything with taste yet?
Taste and smell are very hard. Smell, for instance, is represented in the brain differently in each person, and the first layer of perception is kind of this random assortment of neurons that don't adhere to a certain structure. So it's kind of hard to figure out how you would translate the chemical property into the right representation for someone's brain. So there hasn't been a lot of work in that sort of thing. But you could use a chemical sensor that picks up on something that people can't smell, and then sort of reads out into a device. Like if there's some harmful substance,
the carbon monoxide monitor,
exactly,
with sound.
Exactly.
Yeah.
And you can do not just carbon monoxide, but you could do other kinds of harmful toxins, or you could do radiation, for instance. So when people are exploring like nuclear reactors, for instance, they might carry around a device that beeps when the radiation is too high. So that's another sort of new type of sense.
So this isn't just, we've got 5 senses and why isn't that plenty? This is actually real uses for it. It's protecting us. It's helping us in other ways.
Yes.
So it's not just, because we're flippant, because we want a 6th sense, because
right.
We want to try it, we want to augment ourselves. There's actually really some really good reasons behind some of these.
Yeah, so it's not just being curious, it's not just being greedy and saying, oh, that animal has a sense that we don't have, we want that too. There are very practical uses for some of these things.
Have you noticed what the barriers to entry on some of these things are? So I can imagine, I wear glasses, and having to wear glasses, put them on my face, it's annoying at times. When you go out on the water, or it's you put a mask on and they steam up. Do you see any other barriers to entry on some of this 6th sense stuff?
Yeah, there are some barriers to entry. For instance, cost. Some of these devices are expensive or will be expensive when they're finally fully developed and marketed. There's inconvenience of maybe having to put on and take off something or having to carry something around. There's distraction. Some of us are still overwhelmed by the senses that we have and the distractions around us. If you're starting to add new senses, it's a lot to manage. And then some of these things require or could require surgery. So not everyone wants a new chip in their brain or open skull surgery. Then there are also some ethical questions. There's inequality. Not everyone will be able to have access to these things, partly because of the cost. So if some people have super senses or extra abilities that other people don't have, that could lead to some difficult choices that we have to make as a society about how and when and who can use these things. And then there's an issue of communication and solidarity. To some degree, we all share the same senses. Some people don't have all of their senses, but there is some commonality there. And it sort of puts us in somewhat of the same plane space, the same reality. And if people start gaining new senses or changing their senses dramatically, that could lead to problems in communication and in seeing the world the same way, sort of like the filter bubbles that we see online. Imagine if it's not just people reading different Twitter feeds, but it's people experiencing the world around them completely differently.
I'm thinking the blue and gold dress or the black and gold dress.
Exactly.
Caused uproar, and that was just a dress.
Exactly.
Not including the senses that are replacing senses that have lost or weren't there, but the sixth senses. How widespread is that technology? And let's not include military in that.
Right. I would say it's not very widespread. So these things of like people implanting magnets or putting chips in their heads, that is pretty rare.
We can replace one sense with another. Is it worth it? Should we be doing it?
So sometimes if you want to add more information to one sense, it can become overwhelming. So for instance, there's a neuroscientist at Stanford named David Eagleman who has a company called Neosensory, and they have something they call a vest. You could feed lots of types of information into this vest. You could use the vibrations to detect, for instance, the stock market, or if you're controlling a drone, you could sort of feel what the drone is feeling. Or you could use it as kind of a video screen. And why wouldn't you just have that information displayed on your computer monitor? It's because tracking lots of things visually is very hard. But the body is used to walking and moving in the three-dimensional world using hundreds of muscles, and it can track all of those things in parallel at the same time. So instead of trying to track lots of things with your eyes at the same time, you could maybe track one thing visually and then have other things, instead of also being sent to your eyes, you could send those to your body and sort of intuitively sense these things in a more natural and manageable way.
So yes, so just like the Navi Belt, where's north, you don't need to look at the compass, it's vibrating around your waist.
Exactly.
So where do you see the future of this all going?
So in the future, I see the application of technology to this other use of the term sixth sense, ESP. So there's some research on this where people wearing EEG, which detects electrical activity in the brain, that can send a signal to someone else who is wearing an electrode array that sends signals to the brain. You can wear it on the outside of over your hair. And so if one person thinks something like yes or no in answer to a question, it can stimulate the other person's brain over a wire or wirelessly, so that they might see a flash of light in one area versus another area indicating yes or no.
Oh, so telepathy.
Yeah. Yeah, it's a rudimentary form of mind reading.
Wow.
And so I could see people, maybe more distant future, especially if you have brain implants that can do sort of high resolution input and output, transmitting their thoughts to each other in that way.
Oh, that's been really interesting. Thanks ever so much, Matthew, for joining us.
My pleasure.
I've come back outside, but I haven't got a compass with me. And yeah, I'd really like to know where north is. It's amazing that something so simple as a little haptic motor, as a vibrating motor, can give this sixth sense, another sense, to people. And I had not even considered that it would be of so use to people who are blind. Now, what I really want, apart from a north finding sensor, is an ice cream finding sensor. Because I think I'm done with this episode, but I still want an ice cream. The Engineering Edge was a Why Did the Chicken production for DesignSpark. It was hosted by me, Professor Lucy Rogers, and produced by Tiffany Cassidy, with Dan Page as the executive producer. Special thanks to our guests Susan Wache, Dario Madani and Matthew Hutson. If you enjoyed listening to the show, please do 3 nice things for us. Subscribe, rate us on iTunes and tell a friend. For more episodes and bonus content, head to designspark.com/podcasts. Ice cream eating noises. Nom nom.